Now, as we continue working with quadratic equations, what we're going to talk about now are the transformations of quadratic functions. And we want to be able to use completing the square to write quadratic functions in the form y equals a times x minus h squared plus k, and also describe the effective changes of a, h, and k to the graph of a function in the form, in this form, which is my vertex form. Y equals a parentheses a x minus h squared plus k. Now, in doing so, what we're going to find is the transformations that we're going to be looking at will be translations, reflections, and dilations. So quickly, you should remember from what you've gone through in previous algebra courses is that A can do the reflection and the dilation, H is going to do the translation side to side, K is going to do the translation up and down. So just some of those things. And of course, as we talk about the quadratic function, the parent function is going to be x squared. So if we look at that in a y equals 1 times x minus 0 squared plus 0, or y equals x squared. So that's what that would look like in its transformation. So we, in looking at it, we have moved side to side 0, we have moved up and down 0, and we are neither dilated nor stretched, or stretched nor shrunk, because we are just by a factor of 1, which is itself. So that's what we're going to be looking at as we start to examine these transformations. Now, starting with our vertical translations, that is going to be something added to. So we might have y equals ax squared plus k, and in this case, we're going to say that a is equal to 1. And then k is going to be the y value, which is going to, y values increase or decrease depending on if it is moving upward or downward. So if k is greater than 0, we're going to see a upward shift. And then if k is less than 0, we're going to see a downward shift. So looking at this, if I have y equals x squared, and that is going to be the parent function, and that is going to look something like that. And that, we can do the xy's, right? So as I put in values of x, get out values of y, well, 0 is 0. When I have x is 1, we would get 1. If I have it negative 1, we would get 1. If I have x is negative 2, we'd get 4. And if x is positive 2, we would get 4. So I just plotted those 4 points. But that is the parent function, and we're always going to see those 4 points on the parent function. So when I go to do a vertical shift, so if I have y is going to be equal to x squared plus 4. Well, if I go ahead and do my xy, of course, I'm going to have negative 2, negative 1, 0, 1, and 2. And then when I go ahead and do my substitution here, we're going to be adding 4 to it. So instead of having negative 2, 4, it's going to be negative 2, 8. And doing the substitution again, I have y equals negative 2 squared plus 4, and then y would have equaled 8. So that's how I'm coming up with that value right there. So I have 8, 8, I have 4, 4, and 0. Sorry. And sorry, not 4, duh. So y equals 1 squared plus 4, which is going to be y equals 5. So 5, 5, 4. So when I go to graph that, and I'm going to graph it in orange, I'm going to have these points. And hopefully you can see that that function has just moved up 4. So if we look at it closely, we can see that we had x plus 4, x squared plus 4, so we had this parent function, and we went up to 4. So it looks like all my points went up 4 because my y value is increased by 4, that plus that we were throwing in there. And if we do it again, and we look at possibly -2, and I come over here and I say y is equal to x squared minus, how about -6? So I'm going to use the same y values, right? I'm going to have x and y, sorry, same x values, sorry. -2, -1, 0, 1, and 2. And I'm only using these values too because they're right around the axis here where I'm working. So when y is -2 squared minus 6, that is going to be y is going to be equal to -2. When y is when x is -1, we're going to have y is going to be equal to 1 minus 6, or -5. And then when x is 0, we have 0 squared minus 6, or -6. So in graphing that one, if I graph it in green, come down here to -2, -4, -6. And there we have it. We have moved that one down 6. So 2, 4, 6, it is down 6. So we shifted it down. So you can see the vertical up and down y is going to be dependent on what is the k value outside. What is the k value outside the parentheses? And if we were to look at that in vertex form, again, it would be y is equal to 1 times x minus 0 squared minus 6 is this guy right here in vertex form, because it was shifted left to right 0, and it is not being stretched or shrunk. Your horizontal shifts are going to be very similar, but we're going to be going side to side. So when we look at a horizontal shift, we are going to have y equals a times x minus h squared. And then, of course, we're going to say a is going to be equal to 1. And then if h is greater than 0, we're going to shift right. And then if h is less than 0, we're going to shift left. Now it's opposite signs. So if I were to say y is x minus 3 squared, technically this is a 3, so that is going to shift right. And then, so this is 3 units right, because it is greater than 0. And then if I have y is equal to x plus 2 squared, that is going to be, if we rewrite that, that looks like y equals x minus, right, because that's my formula, minus a -2 squared. And that equals 2 units left, because that is a -2. It is less than 0. So when we go to graph those, remembering that parent function, right? This is y equals x squared, and then when I go to shift left 3 units, I would go 1, 2, 3, and then have the same shape, just shifted left. And then of course if I, shifted right 3 units. 1, 2, 3. And then shifted left 2 units would be 1, 2. There you go. So that is shifting left and right, up and down. So looking at combining these, if we have y is equal to x minus 2 squared plus 3, what we're going to look at that and say, hey, this is going to be h is greater than 0, so we are going to be going right 2, and then k, we are going to be going up 3. So we start off at our original function, and we're going to go right 2, up 3, 1, 2, 3, and then we have our parabola forming. There you go. Looks something like that. And then, of course, this is y equals, I should have done it in the other color, my bad. And then if we wanted to do a different one here, and we'll say that y is going to be equal to x plus 2 squared minus 3, and that would be y is equal to x minus, right, a negative 2 squared minus 3. So I'm going to be going down, left 2, and I'm going to go down 3. So I'm going to go 1, 2, down 3, puts me right there, and do my parabola shape. Looks something like that. And of course that is going to be y equals x plus 2 squared minus 3. So just putting them all together here. Now in order to figure out x squared, a is going to stretch it, or it is going to dilate it. It's going to either make it big or it's going to make it small. And it's often referred to when a is greater than 1. That is going to be a vertical stretch, right? We're stretching upwards. When a is less than 1, that is going to be either a horizontal stretch or a vertical shrink. So we'll call it a shrink. And then when a is less than 1, it is flipped. Flipped. When a is less than 1 but greater than negative 1, this is when you have a shrink. And so what that means here is if we know that the parent function looks something like this, and that is me just plotting the first 4 points, and that is y equals x squared. Now, if I have y equals 2x squared, well, that tells me for all my values of x, I'm going to square it and then multiply it by 2. So when x is negative 2, when I square that, negative 1, 0, a 1, and a 2. So when x is negative 2, I'm going to go ahead and put that in there. That's going to be 2 times 2 squared, which my y is going to be 8. Then when I have negative 1, that's going to be 2 times negative 1 squared, which is going to be 2. And then if I have 0, well, 0 times 0 is just going to give me 0. And now what we can see is when we stretch this, this is going to be somewhere up there like that. I'm estimating where 8's at because it's off my chart, off my graph. So there we go. And what we've done is we have stretched vertically. As you can see, it gets closer to the y-axis. And if you notice, my parent functions, those values were 4, 1, 0, 1, 4. So as you can see, we multiplied all my y values by 2 to end up getting that stretch effect. Now, if I go ahead and I see a shrink would be possibly y equals 1/2 x squared. And in that case, when I have my x's, and I'm going to have 1/2 times negative 2 squared, right? Because I'm going to stick with these same values because it's right now it's just easy. My y value then would be 2. And then I would have 1/2 times negative 1 squared, which is going to be 1/2. 0 is going to be 0, and then my other numbers are going to end up becoming the same. So as I graph that, I'm going to have 0, of course, and then negative 1 is going to be 1/2. 1 is going to be 1/2, and then 2 is going to be 2. And as you can see, it's starting to get a little bit more flat, a little bit more bowl-shaped. So this is a shrink because it seems to be getting closer to that axis, where a stretch is getting closer to that axis. So things to consider. And then when we have x's less than negative 1, we're going to, or when it is negative, when a is negative, it is going to reflect over the x-axis. So if I take and I have y is equal to negative x squared, that is going to be the same shaped function, just flipped over the x-axis. There you go. Just flipped over the x-axis, because that's what the negative does, is it? And those points, if I had graphed them, would have been x is negative 2, negative 1, 0, 1, and 2. And when I plugged it into this thing, that would have been negative times negative 2 squared, which is negative 4. This would have been negative 2, 0, negative 2, and negative 4 again. So again, just doing some substitution and evaluation to figure out my points. And then if you put it all together, what can we do here in order to get into vertex form? Using my vertex form, I needed to make sure that when we complete the square, going back to completing the square, one of the first things we had to do was make sure that this coefficient was 1. So what I'm going to do is I'm going to do some manipulation here, and I'm going to factor out a 6 out of these first two terms so I can complete the square. And in doing so, now I have done some completing the square here. Or I've set it up to complete the square. And remember, when we do completing the square, we write it in terms of y first, and it is. And then next we go ahead and we separate our variables and our constants, and then we will go with taking half of b and squaring it. So right here, half of b is going to be 1. So I'm going to take 1 and square it, which is going to just give me 1. And if I add 1, I have to subtract 1. So I'm going to pull that negative 1 now. I'm going to pull this negative 1 out of the parentheses. And by doing that, or should I say, I'm not going to pull it out. I'm going to go ahead and just move it outside the parentheses when I initially put it here. So I'm going to subtract 1. I added 1, I'm going to subtract 1, but you have to remember that we have this is being multiplied by everything in the parentheses. So I'm not just subtracting 1, I have to subtract 6, because -1 times 6 is going to give me that. So when I rewrite this now, I have y is going to be equal to 6 times, now I can complete the square, and that is going to be x plus 1 squared minus 16. And when I go to graph that, I could graph this over here on this, but I'm going to have to do some manipulating of my numbers, and it might just be easier to erase those numbers and know that my y is -16. I'm going to be shifting downward 16 points, and I'm going to be stretching it by 6. And I'm going to, this is x minus a -1 minus 16. So I am stretching by a factor of 6. I am moving it left 1 unit, and I am moving it down 16 units. And my vertex, which we really didn't talk about, is going to be h and k, which in this case is going to be -1, -16. So way down here, and then it's going to do this. Something like that. But anyway, perfection's not necessary in this case. I just wanted to make sure you're getting a feel for the transformations. So again, transformations of quadratic equations, working with y equals a times x minus h squared plus k. This is an expansion factor or a shrinking factor. H is going to move it either right or left. K is going to move it up or down. And then if a is negative, it will flip over the x-axis. So we're going to get some practice with this, and then we'll come back to it.